Hi everybody, welcome to week 3, term 4, year 5 maths. This week we are looking at fractions for the whole week, and this is lesson 1 where we are adding mixed numerals with the same denominator. So just a quick refresher, a mixed numeral is where we have a whole number, like the number 1 here, which represents a whole. So we've got a whole pie or pizza here, and a fraction that are joined together. So here we have 1 whole and 3/4. And we can see here that the whole has been divided into 4 quarters and 3 of them are shaded. Both wholes are the same size. So this 3/4 is 3/4 of a whole that is the same size as this one. We are adding mixed numerals, so things like 1 and 3/4 with other mixed numerals that have the same denominator. And remembering that the denominator is the number that comes at the bottom of a fraction. It's not the number on the top, that's our numerator. It's telling us how many parts a whole has been divided into. So here, our denominator is 4 or quarters, so our whole has been divided into 4 equal parts. All right, so we're adding mixed numerals with the same denominator, and we're going to do that using 2 different strategies. The first one is using diagrams to represent adding mixed numerals with the same denominator, and the next one is using a written strategy. So diagrams. So diagrams are drawings, and they're particular types of drawings that are meant to show us something or demonstrate something to us. So here we have 2 mixed numerals, 3 and 2/5 and 1 and 1/5, and they both have the same denominator, which is a fifth. So what we want to do is add these 2 together. Now you might know the answer to this already, but it's not just about knowing the answer, it's also about being able to demonstrate and to show your answer and to prove your answer. Mathematical thinking isn't just about coming up with the right answer, it's also about communicating and also demonstrating using different and flexible ways. So diagrams are a fantastic way to show mathematical thinking. So I'm going to demonstrate how to show this particular problem as a diagram or a drawing. So what I've done here, I've used a line model, which means I've created a line like this one here, and I've divided it into 5 equal sections because we're talking about fifths. So I want it to be split into fifths, even for my whole parts. So here, all the blue shading represents 3 and 2/5. So here I've got 1, 2, 3 holes, and those holes are split into fifths. And then I've got a 4th hole, but only 2/5 of it have been shaded blue. So this here, the blue side on the left-hand side, represents 3 and 2/5. On the right-hand side, for 1 and 1/5, I've used pink. So I've got 1 hole, and I've divided it into 5 equal sections and shaded the whole thing because that's 1 hole. The whole thing is shaded. And here I've done another one where I've split it into 5 equal sections but only shaded 1 of those. So I've got 1 and 1/5. Now, to see what this totals to, I've got 1, 2, 3, 4 holes and 1, 2, 3/5 left over. So this diagram here demonstrates that 3 and 2/5 plus 1 and 1/5 equals or is the same as 4 and 3/5. Let's look at another example. Here I've got 2 and 4/5 plus 4 and 4/5. Again, I'm talking about fifths, so I'm going to use my line model here. And what I'm going to do is I'm going to have 2 holes that are shaded blue for my 2 and 4/5, and then 4/5 that are shaded blue. 1, 2, 3, 4. Now I do my 4/5, so 4 and 4/5, sorry. I have 4 holes on this side, 1, 2, 3, 4. And this time I'm actually going to put one of my fifths here from the 4/5 to make this a complete whole, this one here. And the remaining 3/5 I'm going to put here, 1, 2, 3. And so what I need to do is I just need to add them up. So I've got 1, 2, 3, 4, 5, 6, 7 holes. So that's represented by my whole number here. And I've got 1, 2, 3 fifths here because I've got a whole that is divided into 5 equal pieces and 3 of them are shaded. So that's 3 fifths. Now you could either use this strategy on the left here where you can keep them separate, or you can use the one on the right here where I've put the pink in with the blue to create a hole and then use the remaining fraction here on its own to have 3 fifths. Either demonstrates this fine. It doesn't really matter which one you use. The main things that you need to look out for are showing that your whole is divided into equal parts. That's one of our main things about fractions. That your wholes are all the same size, and that we can easily differentiate or show the difference between this fraction here and this fraction here. That's why I've used different colors. Okay, so before I mentioned using a line model to represent adding two mixed numerals or two fractions, we can also use other types of diagrams or models to represent this. So let's look at this one here. I've got two mixed numerals, 2 3/8 plus 3 6/8. I've already written the answer, which is 6 1/8. But what I want to show is how I can use that doing a different type of model. Now, before I said I had a line model, but that's because I had a line and I divided it into 5 equal parts and shaded in a relevant number of parts. I can also use this area model, which is very much like a line model, except that it stacks different lines here, and it works quite nicely for 8 because I've got two rows of 4 to make 8. Again, similar principle. I've got one hole here, so I've got two holes, so 2 holes and 3/8. And here I've got 1, 2, 3 holes, and I've actually put 5 of the 8s here, and the remaining 1/8 from the 6/8 here. So now my total is 1, 2, 3, 4, 5, 6 holes and 1/8 down here. Now make sure that you still represent this as a whole, but only shade in the 1/8. This shows that you're talking about a fractional amount of a whole rather than just a separate object by itself, or you're just going to, someone might think, oh, this person means to show 6 times 8 plus 1, so they're trying to show 49. This actually shows we're talking about fractions. So make sure that this part down here is still a whole, but you only shade in the fractional amount. Another way we can show this is using a region model, which you might also know as a pie chart model. So here we've got the same number sentence, and with the region model, it looks like this. So we've got circles divided into 8 equal parts and the relevant amounts shaded. And again, we get the same answer, it's just represented differently. Now, one thing I forgot to mention is that with the line model, the area model, and the region model, I think the area model is the easiest one to represent either on paper or on a computer. I would probably recommend using that for the rest of the week. It's much easier than a region model, but particularly with a region model, you have to figure out how to space the lines. Now that's quite easy if it's an even number, but if it's an odd number, it's much trickier. And with a line model, if you've got a large denominator, the line model can be a little bit unwieldy. It can get a little bit too long. That's why there's the advantage of the area model where you can have the different rows and columns. Okay, now let's move on to written strategies. So here we've got our two mixed numerals, 2 4/7 and 4 3/7. Now I can first see that these mixed numerals have the same denominator, so it's 7ths here. Now what I want to do is I want to split it apart, so I'm adding the whole numbers first, and then I'm adding the fractions together, because I can add these two fractions because they have the same denominator, so I'm good to go. So 2 plus 4 is 6, and 4/7 plus 3/7, well, 4 plus 3 is 7. We're talking about 7ths, so now I have 7/7. Okay, now whenever I see a fraction that has the same numerator and the same denominator, I know that I'm talking about a whole. I've got a rectangle that's been divided into 7 equal parts and all 7 are shaded, so the whole is shaded. So 7/7 is equivalent to 1. So 6 plus 1 is 7, so my answer is 7 to this one. All right, here we've got 5 and 8 ninths plus 4 and 7 ninths. Again, two mixed numerals with the same denominator. We're talking about ninths now. Just like over on the left, I'm going to add my whole numbers together. Then I'm going to add my fractions together. So 5 plus 4 is 9. 8 plus 7 is 15, and we're talking about ninths here, so I've got 15 ninths. Now, what I want to do here, I can't have 9 and 15 ninths expressed as a mixed numeral. It looks a little bit strange. So what I'm going to do is I need to think about how I can convert this improper fraction now. It's improper because the numerator is larger than the denominator. What I want to do is I want to think about this as saying 5 divided by 9, because that's what this actually tells us. It's a self-contained division problem. So 5 divided by 9, well, I know that I can divide, sorry, not 5, 15 divided by 9. 15 divided by 9, 9 goes in once, and I have 6 left over, and I'm talking about 6 ninths. So I end up with 9 plus 1 and 6 ninths. And then add those together, I end up with 10 and 6 ninths. Now, if you ended up with this and you're like, yep, I'm done, that's totally fine. If you wanted to simplify this, well, I know that 6 and 9 can both be divided by 3. So 6 divided by 3 is 2, and 9 divided by 3 is 9. So my simplified answer is 10 and 2/3. Okay, so the main ideas from today's lesson. Well, we've been adding mixed numerals with the same denominator. We've done it two different ways, using diagrams and a written strategy. Now, firstly, there are three main models we can use for our diagrams, for our drawings. We've got a line diagram, an area diagram, or a region diagram. I prefer the area one because it's nice and simple to do. Make sure in your diagrams that the holes are the same size. So if they're different sizes, your diagram is broken. It's not showing mixed numerals and fractions. Each of the holes need to be the same size. The same goes for each of the fraction parts. They also need to be the same size. Now, I know it can be a bit tricky if you're drawing it by hand, but please make sure you do it to the best of your ability. Also, any fractional parts are always represented as part of a whole. So even if you've got 1/8 left over, make sure that you show that as part of a whole. That's not a particularly great diagram because they're not equal sizes, but you know what I mean. So you'd shade this part in. Now I know you're talking about 1/8. Whereas if it's kind of by itself out here, I'm not exactly entirely sure what you're talking about. Also use different colors or patterns to distinguish the shading of the two mixed numerals. So I used blue and pink. We know that the total shaded parts are what the sum or the total is, and the different colors show us that you've combined two different mixed numerals. For the written strategy, I like to add the whole numbers and fractions separately. Make sure you convert the improper fractions to mixed numerals, so improper fractions where we have a numerator that is larger than the denominator, and we can convert that to a mixed numeral by dividing the top number by the bottom number. So here we've got 7/5. 5 goes into 7 one time with 2 left over, so we have 2/5. Then you add all the numbers together and then simplify if possible. So here we've got 4/6, for example, 2 and 4/6. I can simplify the fractional component by dividing it by 2. So 4 divided by 2 is 2, and 6 divided by 2 is 3. So that's a simplified version. They both mean the same thing. 2 and 4/6 is the same as 2 and 2/3. All right, guys, thanks for joining me today. I'll see you tomorrow. Bye-bye. Welcome back. We're in week 3, term 4 for lesson 2, year 5 maths. Today, we are using diagrams to represent subtracting unit fractions from a whole number. Now, a unit fraction is a fraction where the numerator, the top number, is 1. So here we've got 1/5. So if I had a whole and I'd split it into fifths, 1/5 is the smallest fraction I could have, or fractional amount I could have of that whole if it was split into fifths. Here I've got 1/2, 1/4, 1/14, 1/16, 1/6. They're all unit fractions. So that's what we're looking at today. Okay, so we are using diagrams to represent subtracting a unit fraction from a whole number. Today, make sure you draw the wholes the same size, the fractional parts are the same size, and compared to yesterday where we shaded the parts that we were adding together for the mixed numerals, today we're shading the subtracted fractional part. So if I was subtracting 1/6, I would shade 1/6 of the whole. Okay, so let's look at diagrams subtracting unit fractions. Now today I'm going to be using the area model, which I showed yesterday. So here I've got one whole, which is 1, minus a unit fraction, which is 1/12. And I know it's a unit fraction because the numerator is 1. So what I do is I draw a shape, which here is a rectangle. I divide it into 12 equal parts. So here I've used columns and rows, or an array. So I've got 3 rows of 4, or 4 columns of 3 to make 12, and I've shaded one of those blue. So that's the subtracted part, and what's left over is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that shows subtracting a unit fraction from a whole number in a diagram. Now I can also do this for whole numbers that aren't 1 because they also represent wholes. So provided this is a whole number, that's a counting number, 1, 2, 3, 4, 5. It's not a mixed number with a fractional component, or it's not a fraction. So here I've got 3 wholes, 1, 2, 3, and I'm subtracting 1/8. So I've divided each of these wholes into 8 equal parts, and I've shaded one of them, which is my unit fraction, blue. That's left me with 2 wholes, 1 down here, 2 down here, and 7 eighths. 1, 2, 3, 4, 5, 6, 7. There you go. So you can see how this is kind of like the inverse or the opposite of yesterday, where we were using diagrams to show what would happen when we're adding mixed numerals. Here we're just subtracting a unit fraction from a whole, and we're kind of adding up the remaining parts here to show what would be left over, what's the difference. Now that's all that's really involved with subtracting unit fractions. So what I'm going to do now is I'm going to show you how to subtract other fractions from whole numbers, because I feel like today is very simple, and some of your activities, I started off with unit fractions, but I've gone into subtracting just regular proper fractions from whole numbers, just because this is very simple. So now let's look at subtracting just a proper fraction from a whole number. So this time around I've got my 1 whole again, and I'm taking away 5 twelfths. So instead of just colouring in 1/12, now I just need to shade in 5. Then I need to add up or count the remaining 12ths. 1, 2, 3, 4, 5, 6, 7. I also know that 12 take away 5 is 7. So my answer is 7/12. I can again also do this for a whole number that is larger than 1. So here I've got 3. And I'm actually going to subtract an improper fraction this time, just to make things a little bit interesting. So here I've got 3 minus 15 eighths. So I'm going to have my 3 wholes, 1, 2, 3, and I'm going to divide it into 8 equal parts for each of those wholes, 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to shade 15 of those. So 8 plus 7 is 15. So I'll shade in 1 whole here and 7 of these ones. That leaves me with 1 whole and 1/8, which is my difference, my answer. Okay, and that's all there is for today. So wrapping up, we're subtracting unit fractions from whole numbers. Unit fractions are fractions where the numerator is 1. So here we've got 1/7. That's a unit fraction because the numerator is 1. When we're drawing our diagrams, all of the holes need to be the same size. So let's say I've got 3 minus 1/7. I need to make sure these 3 holes are all the same size, regardless of what diagram I'm using. Then I want to make sure that I split each of these holes into equal fraction parts. Now, because I'm dealing with sevenths here, I want to split it into 7 equal parts for each of these. And then the shaded part is the subtracted unit fraction or the subtracted fraction. So here I'm subtracting 1/7. I would only need to shade 1/7 of one of these holes here. And that's it for today. All right, I'll join you tomorrow for our last lesson of the week. I know it's a Wednesday. We've only got one more content point to cover. Then Thursday will be some fraction revision from things this week and also earlier on in the year. All right, see you then. Hi everybody, welcome to lesson 3 for year 5 maths in week 3, term 4. It's a Wednesday. We're doing our last video lesson for year 5 maths for this week. Today we are solving word problems involving adding and subtracting fractions with the same denominator. So applying some of those strategies we've been looking at on Monday and Tuesday to solve word problems. Okay, so today to do this successfully, we need to recognize whether the problem involves addition or subtraction. So like any word problem, you need to determine what operation to use. And then use a strategy, either a diagram, a written strategy, or a mental strategy if that's available to you. Now, if you can do this mentally, you're like, well, I know the answer to this, it's just this, and it's correct, that's fine. But I want you also to be able to demonstrate using a diagram and a written strategy as well. So to actually have a proper understanding of fractions and this area of fractions, you need to be able to do all 3 of these, not just one of them. You might want to go, well, I like diagrams because they're quite useful. That's fine. If you want to use that, that's fine, but you still do need to master the other 2 strategies, in particular the written one as well. The mental one, it takes a while, it takes a lot of familiarity with fractions. So if you're at this mental stage here of like, well, I can already see what the answer is, you also need to be able to communicate or represent that in writing and as a diagram as well. 2 different skills. All right, so let's start off with an example. I eat 1/5 of a chocolate block and you eat 3/5 of the same block. How much of the chocolate block has been eaten? So let's look at a diagram, a written and a mental strategy. So for my diagram, I'm going to draw a line diagram. I've done a hole, so 1 whole bar. It's been split into 5 equal sections, so that's my fifths. What I'm going to do is I'm going to shade 1/5 blue and 3/5 pink, and that shows me that of this whole, 4/5 have been shaded, so 4/5 have been eaten. That's what this question's asking me. It's not asking me how much is left, it's asking me how much has been eaten, so I need to add these 2 together. I could also work the other way around. I could also start with a whole and then subtract 1/5 and then 3/5. But this kind of gives me, and it would show me that 4/5 have been eaten, but I like this addition strategy because it makes it nice and clear that this is the answer. We can also show this in writing as well. So I know that 1/5 plus 3/5, well, I'm adding 2 fractions with the same denominator. So I don't need to add the denominators. I never add the denominators with fractions. I only add the numerators. So my answer is 4/5. It's not 4/10. That's something completely different. If you make it 4/10, you've actually made this fraction smaller than it is. So you never add the denominators, please. Never add the denominators. All right. Lastly, a mental strategy. If you knew this, you might just think it's in your head. You don't need to write it down. Well, I know that 1/5 and 3/5 both have the same denominator and can be added. So if 1 plus 3 equals 4, well then 1/5 plus 3/5 must equal 4/5. So that's showing an understanding of fractions with the same or common denominator. Let's look at another problem now. Ben ran 5/12 of the cross-country course, then walked another 3/12. How much of the course does he have left to go? Okay, so I'm going to first decide, is this a subtraction or an addition problem? Well, if I think of the course as the whole course, I can represent it as 1. And then he's already ran 5/12 and then also another 3/12. So he's already done that part of the course, so I can subtract these two parts to find out how much he has left to go. That's the difference between how much he's done and how much he's got left to go. Anytime we have left in a word problem, it generally indicates to us that we're thinking about a subtraction problem. We're trying to figure out the difference, which as we know is the answer to a subtraction problem. So let's look at a diagram for this. Well, I'm going to use an area model, and for this model, I'm going to split it into 12 equal parts. So I've got one whole rectangle here, because the 1 represents the whole course. I've divided it into 12 equal parts. You could use a line diagram if you wanted to. That kind of goes nicely with the cross-country theme being a journey. I've shaded 5/12 blue and 3/12 pink. Now that leaves me with 4/12 that are unshaded, which represents what is left to go on the cross-country course. So how much of the cross-country course he's got left to go. Because I've only been given the fraction information, I haven't been given how long the course is, I can only represent my answer as a fraction. So here I can represent it as 4/12, but I can also see that 4/12 is the same as or equivalent to 1/3. Because here, if I divide this into 3 equal parts, 1 and 2, and the bottom one is 3, I can see that 2 of them are shaded, which is 2/3. So he's done 2/3 of the course, and 1/3 down here hasn't been shaded, so he's got 1/3 of the course left to go. That's if I wanted to simplify it to bring it down to the smallest fraction representation possible. What about a written strategy? Well, here, sorry about the animation there. Here I've got 12/12. I know that because the numerator is the same as the denominator, it equals a whole, equals 1 whole. So 12/12 is the same as 1 whole. Then all I need to do is just do some subtraction. So 12/12 minus 5/12 minus 3/12. Well, I can do this nice and easily because they all have the same denominator down the bottom. So it really just becomes 12 minus 5 minus 3, which we know 12 minus 5 is 7, minus 3 is 4. And again, I can just do the equivalent fraction by dividing this by 4. And I can also divide 12 by 4, which is 3. And that's my simplified fraction there. Lastly, you can do a mental strategy. Now, there's different ways of thinking about this. This isn't the only way. So if you're just thinking about it in your head, well, you know, a whole minus 5/12 is going to be 7/12. Then 7/12 minus 3/12 is 4/12. Lastly, 4/12 is equivalent to 1/3. You might already recognize that, or you might just know that, you know, 4 divided by 4 is 1 and 12 divided by 4 is 3, so it's 1/3. And there you go. And our last problem for today, 2 cakes have 10 slices each. Year 5 students eat a total of 7 slices, and the Year 6 students eat a total of 12. What fraction of the cake is left? Well, here we've got this word saying total, but it's not really an addition problem so much as this is a subtraction problem because we're talking about how much is left. So again, we're talking about what's the difference. Now, instead of having 1 whole, this time round I have 2 wholes because I've got 2 whole cakes. And they've been divided into tenths because they have 10 slices. Now, I'm going to assume these slices are the same size. Like, what kind of monster cuts a cake and, you know, puts it into different sizes? So let's look at it as a diagram. So here I've got my 2 whole cakes. Now I've just represented them as rectangles because it's nice and easy, whatever works. So here I've divided them into 10 equal parts. The Year 5 students have the 7/10 or 7 slices. So I've shaded those blue. And the Year 6 students have 12 slices. Now, instead of doing 3 here and 9 down here, I thought it might be easier for me to just shade 10 and then 2, because I know 10 plus 2 is 12, and that leaves me with 1/10 here. So that's how much cake is left, 1/10. So this diagram represents that nice and easily. Another way I can do it is using a written strategy. So I know that 10 tenths is 1, but also 20 tenths is 2. So it's 2 wholes, because 20 divided by 10, remembering this is a division problem, 20 divided by 10 equals 2. So I can write it as 20 tenths minus 7 tenths minus 12 tenths. Well, so 20 minus 7 is 13. 13 minus 12 is 1, so that leaves me with 1/10. Okay, and lastly, a mental strategy. Again, you could think about this in many different ways. 12 tenths is equivalent to 1 2 tenths, if you know how to change that. Here, you just divide 12 by 10. You'd have 2 left over, so it'll be 1 2 tenths. Subtract that from 2 leaves 8 tenths, and then 8 tenths minus 7 tenths equals 1/10. So that's if you had a pretty solid understanding of fractions, and you could just do it mentally without having to draw a diagram or do a written strategy. Whichever works for you today, obviously follow the instructions, but you need to be able to do these two at the very least before you start using mental strategies. So if you can do it mentally, that's fantastic, but I also need you to be able to use that skill of representing it as a diagram and representing it as a written problem, either a subtraction or an addition problem. Okay, and that finishes off today's lesson. So a really important thing, which I probably should have mentioned earlier in the week, but hopefully you are aware of it by now, you never add or subtract denominators, and I'll show you why. Here we've got 1/10 plus 2 tenths. Now I know the answer is 3 tenths because we're dealing with tenths. So this is what it should look like here. I've got my whole and it's divided into 10 parts, and one of those is shaded blue and 2 of those are shaded pink. If I was to add the denominators, my answer would be 3/20 over here. Now this diagram here, what I've done is I've kind of stretched it a little bit to show that, well, basically I've kind of cut each of these squares in half to make a rectangle. I've kept the whole the same size, but what I've actually done is my answer has been halved now, because this is 3/20. I've actually made it smaller than it needs to be. So you never add the denominators, otherwise you will end up distorting the final answer. So this is why you never add the denominators, and you never subtract the denominators, because if you subtracted 10 from 10, let's say we switched those around, so it was 2 tenths minus 1/10, you would end up with the correct answer would be 1/10. But if you did it the other way and subtracted the tenths, you'd end up with 1/0, which would equal 0, because 1 divided by 0 is 0, and that's not the answer we want. You will always end up with 0, which is always the wrong answer for that problem. So never add or subtract denominators. When you're solving a word problem, visualize the problem, evaluate whether it's addition or subtraction. You can look for keywords, but you really need to have an understanding of whether it's addition or subtraction. In some situations, you could use either, just depending on how your brain works and how you're going to represent it to get your answer. Apply either a diagram, a written, or a mental strategy to solve the word problem. And today, I've put in a few bonus challenge questions where the denominators are different, because I know some people will probably find this a little bit easier this week. So in that situation, you'll need to find common denominators. So here we have 3 tenths plus 2/5. I need to find a common denominator because I can't add these two fractions because they have different denominators. So what I'm going to do is I'm going to multiply 2 by 2 and 5 by 2. So I end up with 3 tenths plus, now instead of 2/5, I am plussing 4 tenths. And then my answer would obviously be 7 tenths. That's just a bonus kind of challenge for some people today. That ends all our lessons for this week on fractions. Like I said, there's no one tomorrow because it's revision.
And it also ends our home learning lessons for maths for now, hopefully. So I look forward to seeing you back in the classroom on the 25th of October. If you have any questions about this work this week, please do not hesitate to contact me. Either send me a private message or mention it on our Zoom chats. And if not, I'll see you back on the 25th. All right, have a good day. Bye-bye.